So here's the final render that we've got from our explosion scene. We got a fairly decent looking explosion. There's a little too much movement for my liking here. There's perhaps a little too much particle turbulence. You can see that some of these chunks on the inside of the effect are moving around a bit too much. They should rotate, but they almost look like they're bobbling. But overall, the impression looks pretty decent. We get a darkening of the clouds. They are popping a little bit rather than fading off with alpha, so that's something else that we could look at improving upon. Notice that I've also got an effect where, as the explosion occurs, we get an immediate brightening of light in the scene, and we can actually look at this on the underside of this brick building. The lights intensify and then die out. And just to show you how that works, if I select the light that I've used to create this effect, I've used this inside of the ice tree. If I select the point cloud, let me move it forward to frame 2 or 3, and I'll open the ice tree. I've gone in and I've set a value, I've set a couple of data nodes, data inputs, on the light explosion's red color and green color. So the first thing I've done there is I've assigned a random value. So I've taken the red color and I've given it a bright, almost close to 1, so high reds, and I've varied those by 0.05. So we get a bit of light flickering, and I've also done the same thing on the green channel. The green channel doesn't quite have the same base value as the red channel, so we're getting a kind of a orangish color. So again, a mean value of 0.5 with a variance of 0.04, and time varying, of course. The other thing that I've done is I've driven the light intensity using the current time F-curve combination I had to drive my rate. The only problem with this branch here is that the intensity of the function curve does hit a value of 0. If I right-click on the end key at frame 1 or at the end of the simulation, we have a value of 0, so there are no particles being emitted. So all I've done is taken that same current time F-curve and I've copy-pasted this function curve, and I've set it so that even when the light or when the rate of the particles die off completely, we take the light and we leave it with some residual intensity. And I've used that and driven it through a divide by scalar node, because if you notice, the highest intensity value on the rate slider is 2,500 particles, and we don't want to have a light intensity of 2,500. My light intensity needs to be around 1 or 2, so 2,500 divided by about 1,600 is giving me a maximum light intensity of about 1.6 or so. And if I select that light and press enter, you can see that the intensity is mapped as the follows. Again, as we start our simulation intensity of 0, we get a very bright intensity initially, and then you'll see that that intensity ramps off very quickly. So right around frame 37, it caps off at an intensity of about 73%. So that's how that entire effect comes together. Again, we could do a lot more tweaking on this, but the procedure for building the explosion is all contained within the last hour and a half, and the rest of it is customization. So I hope you've had a very thorough explanation of how to create this explosive effect, and from here on in you can customize it to meet your own needs. So this finishes the explosion tutorial, and if you want to complement this with particle smoke, I encourage you to have a look at the smoke tutorial earlier on in the simulation series. So that's it for now.